All right, let's jump right in. Welcome to today's Explainer, where we're going to unpack a truly wild and highly conceptual framework for how our entire reality actually operates. We're looking at the cosmic evolution theory today, and specifically, we're focusing on a model put forward by independent researcher Yusuf Al-Rashid in his work, The Fractured Universe. Now, if you're the kind of person who loves pushing past the standard textbook answers to ask those deep, foundational questions about reality, you are absolutely going to love this one. We're exploring a massive paradigm shift here, one that attempts to redefine gravity, dark matter, and cosmic expansion. And it does this not by treating them as separate physical entities, but as interconnected behaviors of one single overarching system.
So think about this for a second. Why does the universe have structure at all? Modern physics is incredibly good at describing exactly how the universe behaves. We know how galaxies form, we know how stars burn, and we definitely know how space-time curves. But Rashid's work points out that our standard models basically bypass a much deeper question. Why is there organized matter in the first place, instead of just a uniform, featureless soup of energy? We are going to completely skip past the how today and focus entirely on the why. We're diving into a framework where the universe isn't built from pre-existing matter, but from underlying structural conditions.
And that brings us to the core philosophy of this entire theory. Quote, existence requires imbalance. In Rashid's model, reality itself, literally everything we can see, touch, and measure, emerges from asymmetry, not from perfect balance. Think about it. A perfectly balanced system produces absolutely no motion, no structure, and no change. So the universe only exists and evolves precisely because it cannot return to equilibrium. The absolute crucial point here is that imbalance isn't some sort of glitch in the cosmic machine. It's the engine of existence itself. Section 1. The mystery of structure. Before the universe.
Okay, consider the concept of a pre-structural state. Try to imagine a maximally symmetric state. In this state, there are zero differences, no variations, and absolutely no gradients. Mathematically, the structural gradient equals zero. Because there is perfect similarity everywhere, there is no motion, no interaction, and no relational structure at all. Sure, the system contains infinite potential, but because it's perfectly balanced, it's dynamically inert. There's no observable reality yet. It is just a state of pure, expressionless unity.
Section 2. The primordial fracture. Symmetry breaking.
Now, the theory defines the transition out of that state as the fracture. But hold on, be careful here. This is not described as an explosion in space or the creation of something from absolutely nothing, like we normally picture the Big Bang. Instead, it's a structural phase transition. It's a global transformation that introduces asymmetry into the system. Suddenly, the structural gradient is no longer zero. And it's this introduction of difference that wakes the system up. It activates latent conditions, it creates gradients, and with those gradients, motion and interaction suddenly become possible. In this view, physical laws aren't just fundamental constants baked in from the start. They are actually the system's ongoing responses to this newly introduced imbalance. So this creates a pretty fascinating hierarchy of emergence. It's like a cosmic domino effect. That initial difference cascades into variations in density. That imbalance forces the system to try and reorganize itself, which naturally creates motion. As that motion stabilizes into patterns, structure forms. And here is a huge takeaway. In this model, laws and structure emerge together. Laws are really just the internal logic of how these new structures behave. And finally, space and time emerge. But they don't emerge as a pre-existing empty container that everything gets dumped into. They merely exist as the relational field and the measure of change between these structures.
Section 3. Redefining matter and gravity. A new perspective. In our standard understanding of physics, matter is the fundamental building block, right? But this framework argues that matter is not primary at all. Actually, it's a localized stability solution. After the fracture, as the entire system tries to deal with this massive imbalance, certain regions hit a local equilibrium. They manage to stabilize. And that stable configuration, locked within a globally unstable system, is what we perceive as visible matter. It is a complete flip in perspective. Matter isn't what builds the universe. It's the localized resolution of cosmic tension. Which naturally leads us to rethink gravity. Standard general relativity models gravity as the curvature of space-time caused by mass, the classic bowling ball on a trampoline analogy. But the Rashid model interprets gravity as structural flow, meaning gravity isn't an independent fundamental force reaching out and pulling objects together. Instead, it's simply the directional motion of matter moving along structural gradients. Because the whole system is imbalanced, matter just naturally flows toward regions of higher structural concentration to find stability. It's not being pulled, it's literally just flowing down the structural hill, so to speak, in an attempt to reorganize the system. Section 4. Rethinking the Dark Universe. Hidden Structures. Okay, let's tackle the big mysteries, starting with dark matter. The standard model generally treats dark matter as an unknown particle. It's missing mass that we can't see, but we know it holds galaxies together. Well, the Rashid model offers a completely different interpretation. Dark matter is simply hidden structure. You see, after the fracture, not all of those structural concentrations resolved into stable, visible matter. Some gradients remained deeply concentrated without ever forming observable particles. These unresolved regions don't emit light, sure, but they still have incredibly deep structural gradients, so visible matter still flows towards them, which creates the illusion of missing mass. Dark matter isn't some invisible ghost particle. It is just the underlying structural framework that's actively guiding the visible matter.
And then there's dark energy. Standard models usually explain this as vacuum energy or a cosmological constant that's causing the universe's accelerated expansion. But what does Rashid's framework say about it? It argues that dark energy isn't a new entity or some mysterious external force at all. It is simply global divergence. Remember, the entire system is fundamentally imbalanced on a massive scale, and it literally cannot return to perfect symmetry. So while local imbalances create structure and gravity, the overall global imbalance forces the system to distribute itself outwards. Cosmic expansion is just the system's global response to an unresolvable structural tension.
The absolutely crucial point to take away here is this. We're looking at a dual cosmic behavior driven by the exact same mechanism, just operating at different scales. At local scales, structural gradients cause organization. Matter clumps together, galaxies form, and we call that gravity. But at large cosmic scales, those exact same gradients cause divergence, tearing things apart, and we call that expansion or dark energy. It is quite literally two sides of the exact same structural coin. And the sheer beauty of this interpretation is that it requires absolutely zero new, undiscovered particles or external forces. It's incredibly elegant.
Section 5. A unified cosmic system, the total state. So, let's look at the core formula of the model. The Greek letter psi represents the total state of the evolving universe, and that equals m, representing visible matter, plus sh, which is hidden structure, or what we call dark matter, plus ex, meaning expansion behavior, or dark energy. Now, this equation isn't describing the composition of the universe like a recipe with ingredients. It's describing behavior. It's a unified mathematical expression showing that the evolution of the cosmos relies entirely on the balance between local stability, hidden structural depth, and global divergence. This is a complete paradigm shift. Every major cosmological phenomenon that we currently treat as an independent puzzle piece is remapped here as just a different response to that initial primordial fracture. Matter, that's local stability. Dark matter, that's hidden structural concentration. Dark energy, global structural divergence. The whole shebang traces back to that one initial loss of perfect symmetry. The universe is really just trying to process its own imbalance.
Now, you might be wondering, what about all our current data? It's really important to note that this theoretical framework doesn't just throw out our current astronomical observations. Not at all. It just seeks to reinterpret them. The cosmic microwave background, that's not just leftover heat from the Big Bang, it's the direct imprint of those very first early structural gradients. Black holes, they aren't just dead stars collapsing, they're extreme structural nodes where gradients reach maximum intensity. And gravitational waves aren't just ripples in space-time geometry, they are propagating disturbances in the structural gradients as the system violently reorganizes itself. The data stays exactly the same, but the lens we view it through changes completely. As we bring this explainer to a close, we hit upon the real profound philosophical summary of Rashid's work. The universe is not a static system governed by fixed external rules. Laws don't just exist outside of the universe waiting around to tell matter what to do. The universe itself is a continuous transformation. Difference creates, deformation transforms, and structure sustains. Everything is continuously becoming, constantly reshaping itself through this one underlying process of dealing with structural imbalance. Which leaves us with this final, provocative thought. If a perfectly balanced void can fracture to create the wildly complex reality we see today, and if existence fundamentally requires imbalance, then is our observable universe just one temporary phase in an endless chain of structural transformations? Seriously, what happens when this current structure reaches its limit? It's a profound paradigm shift that totally invites us to look up at the night sky, not as a collection of separate floating objects, but as a single, beautifully fractured system constantly in motion.